Hello, everyone. Our research topic is analyzing automated breast ultrasound images using deep learning and convolutional neural networks to detect breast cancer. And Bhavya, Gautam, and I will be presenting for you today.
So the problem being addressed is that current cancer detection models analyze X-ray images, CT scans, MRIs, etc. But these current imaging processes, which are used in the current cancer detection models, um, they use radiation or other dangerous wavelengths which can cause cancer. And the chance of getting a fatal cancer from any one CT scan, for example, is about 1 in 2,000. And also, on average in the US, X-rays cost up to $500, CT scans cost up to $3,280, and MRI scans cost up to $12,000. On the other hand, on average in the US, ultrasounds cost up to only $800 and have no radiation. So ultrasounds have like the perfect balance in terms of expense and safety and are the perfect imaging process option in terms of expense and safety. But despite the inexpensive and safe characteristics of ultrasound imaging, ultrasounds lack the sufficient detail to detect small masses of cancer compared to the other methods of imaging. So the question is, can we find a way to detect these small masses of cancer growth in ultrasound images to make cancer detection and prediction more affordable and safe?
Standard techniques to analyze ultrasounds. So firstly, radiologists can't see breast cancer. They can only identify specific spots on ultrasound images that look unusual or improper. This can be an early indication of cancer being present, but in order to confirm it, they need a biopsy. A biopsy is a provider that removes the tissue, cells, or fluids so that proper examination can be performed by a medical expert. Another method used to determine whether cancer is present is mammography, a technique used to detect abnormalities in breast tissue. This is specific to breast cancer, as the errors identified by the exam could potentially lead to cancer long before patients encounter symptoms that justify cancer being present. This breast imaging exam is performed through a mammogram, which is an X-ray scan of the breast. To touch on AI being used in this topic, neural networks have been utilized to detect cancer using MRIs, X-rays, and CT scans. MRI is magnetic resonance imaging, and a CT scan is a computerized tomography scan. Both are processes that create detailed images of the body for an individual to effectively examine. Obviously, there are many other methods, including various other machines such as the Doppler flow machine, etc.
Prior research on the detection of cancer using AI use CNNs, reinforcement learning, and different feature selection algorithms to create a model that can accurately detect cancer. A group at MIT created a model named Sybil, which detects lung cancer in low dosage CT scans. They used a ResNet CNN architecture to extract features from each image. These features were then inputted into a max pooling layer. The pooling layer reduces the dimensions of the feature vector while keeping the most significant features. The final feature vector is put through a hazard layer, which predicts the risk of developing cancer within the next 6 years. The next model was made by Liu et al., and they proposed splitting 2D breast ultrasound images into 8 grids to detect and classify benign and malignant tumors. Their model tests 16 pre-trained CNN architectures and determines the 3 best architectures for classifying breast cancer. The chart on the right shows the 3 architectures, ResNet, MobileNet, and EfficientNet, in bold and their accuracy. They used iterative neighborhood component analysis, which picks out the best features for which the deep neural network will then classify. Here's an image of their model without the prior testing of all 16 CNNs. Finally, Ahmed et al. Proposed efficient neural architecture search to detect breast cancer in ultrasound images. ENAS is a reinforcement learning model that creates 2 optimal cells, a normal cell and a reduction cell. The 2 optimized cells are shown here. They then manually put together a CNN architecture using the generated cells. The 2 created models are ENAS 7 and ENAS 17. These both prove to be more accurate than the AlexNet and CNN3 architectures. Our idea is to develop a deep learning and CNN model that detects breast cancer in automated breast ultrasound images. We are going to run our automated breast ultrasound dataset through the Sybil model and then replace the original ResNet architecture with MobileNet and VGG16 architectures. We also plan to test the ENAS model and let it generate a CNN architecture by itself. Here's a visual of what we're going to do. So we start out with the original Sybil model, and what we will do is change the output to determine whether there's cancer present. We will run our ABIS dataset through Sybil and calculate our accuracy. And then we will replace ResNet with MobileNet and VGG16. And then finally, we will test out the ENAS model and compare model accuracies. You can find our models and data here. And we would also like to acknowledge ASDRP and Dr. McMahon for giving us the resources and opportunity to do this research. Are there any questions?